Okay, so now we're going to go over the second half of your test. So this is all things to do with radicals, okay? And basically you're adding, subtracting, multiplying, and dividing, and simplifying radical expressions. So let's look at number 2. Let me zoom in. Not number 2, number 12, silly. Okay, so here I can only subtract my radicals if my number on my shelf is the same, which they are, and the number underneath is the same. 45 seems like it could be reduced, so let's see if we can reduce it first, and then we'll be able to tell if we can combine them or not. So 45 divided by 5 is 9, divided by 3 is 3. So remember, when you're looking for roots, when we're looking for square roots, we're looking for pairs. So I have a pair of 3's. One 3 goes out, the other goes away, and my leftover number is 5. So it's left over in my root. When this 3 comes out, it needs to multiply by my leading coefficient. So I'm going to multiply 2 times 3. I keep my square root, and then I have a 5 left over, minus root 5. Okay, 2 times 3 is 6 root 5 minus root 5. Okay, so these radicals with the number underneath is like a variable. So for example, if you had 6x minus x, that's pretty much what we have here. We're going to keep the x's the same, and we're looking for common letters or like terms, and then we're going to simplify the leading coefficients. So 6 minus 1 is 5. So this will be 5 root 5. And the reason that we have leading coefficients is to save us time, because remember, they're counters. So really, if I have 6 x's or 6 root 5's, I have 1, 2, 3, 4, 5, 6 x's, and then I'm taking away one of them. So in order to save me time and to not have to write all of this down, we use leading coefficients, so 6 x's, and then it's easier to subtract and easier to write. So that's the same idea in our radicals. All right, multiplying, you can only multiply radicals that have the same number on your shelf. So you can multiply these guys together and you could simplify. So I'm going to multiply my leading coefficients. We're going to multiply 5 times negative 5, and then we have the cube root of negative 15 times negative 40. Now we have negative 25, and negative 15 times negative 40 is 600. And then we're going to factor tree. So I've got 600. I can divide by 10 and 60. If I don't break them up into big chunks and I divide by 2, my factor tree is going to be really, really long. So I like to break them up into bigger chunks. 10 is 2 and 5. 60 is 2 and 30, which is also 2 and 15, which is 3 and 5. Okay, so it's a cube root, so I'm looking for triplets. So I've got 1, 2, 3 2's, and then I have leftover 5, leftover 3, leftover 5. Okay, so one of the 2's comes out and the other go away. So when it comes out, it multiplies by my leading coefficient, negative 25 times 2. And then underneath my radical, I have these leftovers left over. So 5 times 3 times 5, because none of them are triplets. Negative 25 times 2 is negative 50, cube root of 75. Number 14 is very similar to number 15, or number 14 is similar to 15 and 16. These two are just harder versions of 14. So my hint to you on 14 is to distribute. If you distribute, then you're multiplying your radicals just like we did in 13, and I think that you guys can figure that out. I'm going to do 15 with you. So we're going to distribute our radicals. So I'm going to multiply root 3 times root 3. Well, remember, when you multiply a square root times the same number, it's going to cancel out. So what I'm saying is, if I have the square root of 3 times the square root of 3, that's the same thing as the square root of 3 times 3, which is a pair of 3's. This is also the square root of 9, but when you have a pair of the same number in the square root, because we're looking for 2, one comes out and the other goes away. So when you multiply a square root by a square root, the second one cancels and the radical cancels on the first one because it's basically the square root of 9, which is just 3. Okay, so back to the problem. Root 3 times root 3 is just 3. Okay, so that's my first one. Then I need to distribute my square root of 3 to my 5 root 5. So I multiply my leading coefficients. I have 1 here and 5, so 1 times 5 is 5. And then underneath I have 3 times 5. 3 times 5 is 15. And now we have to multiply and distribute this root 5. So I distribute my root 5 to my root 3. Well, 5 times 3 is 15. There are no numbers in front of these square root signs, so I don't have any leading coefficients. Then I multiply my root 5 times 5 root 5. So I have a 1 here, and then a 5, so plus 5. 5 times 1 is 5, and then 5 times 5, when I have the same root times the same root, and they're both squares, then you're just left over with one of those numbers. And it needs to multiply because this was a leading coefficient. So the 5 comes out and the other goes away. Okay, so here I have 3 and 5 root 15 and root 15 and 25, so we're going to combine our like terms. 3 and 25 is 28, and 5 and 1 is 6 root 15. I can't simplify any further because 15 is just 3 and 5. There's no pairs there. So, yeah. Let's see. Okay, number 18. When you have to do this problem, you have a square root in the bottom, so you can't leave the square root there, so you have to rationalize the denominator. So you're going to multiply the top and the bottom by just the square root of 3 to get rid of the denominator. And the square root of 3 is basically 1, so we're not really changing our problem, we're just manipulating it so we can do what we need to. I'm not going to finish this one with you, but I just wanted to let you know that you don't have to take the 3 with you, you just multiply by whatever's under the radical. Instead, we are going to do 17. You could reduce first if you wanted to, but I'm just going to multiply by root 32 because sometimes when you reduce first, then you have to multiply and then reduce again, and that's kind of annoying, so I don't want to. Okay, multiplying underneath our radicals because I have no leading coefficients, so 32 times 3 is 64, and then underneath, remember when you multiply by the same root, it's just that number. On the top here, the square root of 64 is 8 over 32, and then this reduces to 1/4 because 8 goes into 8 one time and 8 goes into 32 4 times. Isn't that fancy? Okay, and then let's do number 20, and I need to tell you about one more problem. Okay, on problem number 20, here again I have that radical, and we need to rationalize the denominator. So we don't want to leave that radical in the denominator. It's not good. So we're going to multiply the top by root 10 and the bottom by root 10. On the top, when you multiply by root 10, you must distribute to the root 5 and to the 3. Okay, so that's my hint for you for number 20. Then you will also have a problem on your test that's similar to this. If you had 2 plus 2 root 2 all over 4 minus root 8. Okay, you have a few different options here. You can simplify your root 8 if you wanted to, but we're not going to. Instead, we're just going to multiply. When you have a problem like this and this are different. Notice that my 5 is getting multiplied by my 10, and here I have a 4 that's getting subtracted. So there's a big difference between the multiply sign and the subtraction sign. If I multiply by just the root 8, I cannot get rid of my radical in the denominator, so instead we have to multiply by the opposite. So we're going to multiply the bottom by the opposite of minus, which is plus root 8. So everything stays the same except for the middle term gets the opposite sign. On the top, you have to multiply the same thing because we're multiplying technically by 1. When you multiply, you have to distribute much like we've done before. So 4 times 2 is 8. Sorry, I'm taking over all of the 20 so you can see because I ran out of page. Okay, and then we have 4 times 2 root 2. So 4 times 2 is 8 root 2. And then I have to multiply by my root 8. So I'm going to multiply root 8 times 2. Oh, I multiplied this wrong. I'm sorry. That should be 2 root 8. My bad. I just realized the radical was under the 8 and not in front. I'm sure you're angry at the video. I'm really sorry. And then, no, it was right. Oh, heavens. I'm struggling. Okay, let's try again. It's weird to backwards distribute. Okay, I like to distribute these numbers and not these numbers because I don't get confused. One more time. 4 times 2 is 8. I had it right the first time. And then 4 times 2 is 8 root 2. Now we're going to keep going. 2 times root 8 is 2 root 8. And root 8 times 2 root 2 is 2 root 16. All right, sorry guys. On the bottom, you can do the same thing, multiply all 4 terms. However, the 2 middle terms are always going to cancel because you're multiplying by a positive and a negative. Oh, sorry. Gotta stand up. Okay, there we go. So the shortcut is to multiply the 2 front terms together. So 4 times 4 is 16. It's always a minus sign. Then multiply the 2 back terms together. When you have a root 8 times a root 8, that's just going to be a plain 8. You could put like plus and then it's negative 8. But if you just always put a minus sign and then not worry about the signs, you're totally fine. Okay, so here, I'm going to simplify this. So 8 reduces to 2 and 4 is 2 and 2. So I have a pair of 2's. So one goes out, the other goes away, and I'm left over with 2. So I'm just going to redo that. And then the square root of 16 is 4. So we're going to simplify some all at the same time. So I have 8 plus 8 root 2. And then I'm going to multiply by this 2 that came out. So 2 times 2 is 4. And then I have a 2 left over, so root 2. And then here I have my 2 times 4 because the square root of 16 is 4. And then 16 minus 8 is 8. Okay, so then we're going to keep going. I can combine my 8 and my 8, and that will give me 16. And I have 8 root 2's and 4 root 2's, which is 12 root 2's all over 8. Here I see that I have common numbers or common terms in front of everything. So I'm trying to find the greatest common factor. So let's see, 4 can go into all of them. 6 cannot, 8 cannot, so 4. Okay, so I'm going to take a 4 out of everything in the top. So 4 out of 16 is 4 left, and 4 out of 12 is 3 left, root 2. And then 4 out of 8 is 2 left. The reason I like to write it like this is because students often get confused and will just divide each of them by different numbers, but they can't. They need to be divided by the same number. Okay, so my 4's cancel, and now I have my answer, 4 plus 3 root 2 all over 2. So this is how you do those kinds of problems. If you have any questions, let me know. Have a great day, guys. Bye.